So let us say this is a function. You can see it is defined in one way when it is less than 2 and other way when it is greater than or equal to 2. And then you are supposed to find f dash 2. Again, as we said, you must find see, all these functions are differentiable in their respective intervals. So in the respective interval, there is no problem. The function will be entirely differentiable for minus infinity to 2. The function will be entirely differentiable from 2 to plus infinity. The problem can come only when there is a change in the definition. Only when there is a change in the definition. So if you want to check the continuity, you can see that the value of the function from the left hand side is 2 plus 1, 3, and from the right hand side it is 4 minus 1, 3. So the function is continuous. The limit is 3 from both the sides. So then we can talk about its derivatives. Now, D is the correct answer. Because, see, in order to find the left-hand derivative, as I said, you have that long discussion which we had in the beginning of this session, plus h minus h. You really don't have to do all that when you actually find it. What you need to do is use the definition for the left-hand side and differentiate it. So when I differentiate this, I get plus 1. That is my left-hand derivative. Then use the definition on the right-hand side and differentiate that. And the derivative of this is 2. So my right hand derivative is 2, and obviously because my left hand derivative is 1 and right hand derivative is 2, the derivative does not exist because they have to be equal if the derivative has to exist. So here if they had asked you f dash 2 minus, the answer would be 1. If they ask you f dash 2 plus, the answer would be 2. But for the derivative f dash 2, both must be equal, and therefore the derivative does not exist is the correct answer. You can see here there's a left hand derivative and right hand derivative are not equal. You can see that they are 1 and 2.